Hello, hello everybody, and welcome back. Welcome back indeed. We're looking at question number 21 on the Cayley contest from the year 2002. It's the very first question to be worth 8 marks, so let's put on our thinking caps, really buckle down, and hopefully we can get not just this question, but all 5 questions in part C. So, in the diagram, the circle has center O. The shaded sector, AOB, has a sector angle of 90 degrees. So they have that little right angle right there already for us. And AB, so the distance from AB has an arc length, so the distance from AB along the circle, is 2 pi units. The area of sector AOB, so the area of this quarter circle is, okay. So we need to start thinking about 2 different things. One, there's a formula in terms of the radius and the angle of the sector that gives us the arc length of a sector of a circle. And there's also a formula in terms of the radius and the sector angle that gives us the area of a sector. Okay. So we're given the question in degrees. You'll often get the question in degrees, but sometimes they give it to you in radians. It all depends on sort of what grade level and what the person was thinking. But let's copy down those formulas or write down those formulas. So any circle we want, if I have a sector, now the one that we have is a 90 degree sector, so it's a quarter of a circle. But for any sector of the circle at all, the arc length has a formula. And let's see. If it was the full thing, it would be... Now let's write down the formula a little lower so I have more space. So I'll admit, I don't remember these ones off the top of my head. I just try and work them out. I know I'm going to have a theta in there, and it's going to be out of 360 degrees. It's like taking a percentage of the circle, or a fraction of the circle. So theta degrees out of 360 degrees. And then if this were a full 360 degrees, this would be 1. And what would I need to get out? Well, I need to get the circumference of the circle at that point, so it would be 2 pi r. So a fraction of the total circumference is just going to be theta degrees out of 360 degrees of the 2 pi r that gives us the regular circumference. So that gives us the arc length of the sector. Now if I wanted the area of the sector, it's the same sort of thing. It'll be a fraction out of the total, and since we're in degrees, the total is going to be 360 degrees. And we have pi r squared. Okay, that's the regular formula for the area of the circle. Sector is just taking a slice or a fraction out. Okay. So now using these 2 formulas, we should be able to get a handle on the situation in the question. Now the question specifically gave us a quarter circle. And we can see if we plug in 90 degrees into both of these formulas, we're just going to get 1 over 4. So we have A, O, B. And we know that 2 pi is that arc length. And we want the area. So to get the area, we'd need the angle, which we have, it's 90 degrees. And we'd also need r. Well, we don't have r. But we have another formula involving the arc length, which we do know the arc length, and we do know our theta, it's 90 degrees. And it should give us r. It's got an r in it. So we know that 2 pi is 90 degrees over 360 degrees, 2 pi r, which is 1/4 2 pi r. So if I divide by 2 pi on both sides, I'm going to get a 1. So 1 equals 1/4 r, and it's not that hard to see at this point. R is going to have to be equal to 4. So we used the arc length information to get the radius. And we knew we wanted the radius because that's what we're missing in our area formula. So all the pieces slowly fit together. So area is 90 degrees over 360 degrees. Pi r squared but r is 4. So we're going to get 1/4 pi 4 squared. There's a 1 4 on the top and another 4 on the bottom. They'll cancel out. And so we'll just be left with 4 pi. So we'll take a look. 4 pi, it's the very first answer. So we go with A. Alright. So that does it for question number 21. Join me in the next video for question 22.